Yeah,
Yay.
that's the magic word.
The magic, yeah, the magic word.
Yeah.
And let's see. Hopefully, I can share my screen. I'm a little scared. Let's see. So I will go over here. I don't know if I have that. Let's see. I'm uh, things are crazy. I'm using the browser, the browser based Zoom,
Okay.
so it's a little
Usually
different.
it's on top, the share button.
Um, yeah, where has it gone?
Usually.
Oh, here we go. Okay, here we go. Yes.
Yeah.
Okay, so I'll share this. Okay, so hopefully that works. Can people see that?
Yep.
Okay,
Yep. Got
great.
it.
Okay, so yeah, chapter two was very straightforward. I think the first short section was about installation. Oh, and by the way, I guess the way this is working, I can't see anybody else. So I think if you want to interject, you might have to uh, chat or grab my attention somehow. Sorry about that. Yes, next week I'll be back on my regular device. So hopefully, but yes, okay. So yeah, the first little bit of this chapter just had to do with installation. So that I think was pretty straightforward. And like one nice thing I think about DuckDB is that it is easy to install. Kind of no matter if you're on Mac or Windows or Linux, it is just like a little binary that you could just kind of run. So I think that is a nice feature. But I'm not going to cover that. I don't know if anyone had trouble installing it, but otherwise, I think probably we'll just forget about that. So yeah, so the goals for today are just to kind of learn how to start and configure the DuckDB command line interface, and just to kind of play around with that a little bit. So yeah, I think the point of this chapter isn't really to learn SQL or anything like that, but maybe just almost like to explore and to get a sense of what the landscape looks like. Uh, so yeah, you can the command line interface. You can start in kind of the shell of your choice, just with this invocation of DuckDB. So that's how you start it. And I do have this little aside here. If you're making Quarto documents and you find that you want to have these DuckDB CLI commands in them, one easy way is to have your Quarto chunk correspond to like the shell that you're using. So in this case, I have Bash, so I have Bash in my chunk description there. So I both in between the two curly braces, and then uh, on the third line, I'm telling the script to use the I'm telling the script like the path of Bash in this for the script. And you can see that Quarto can like run and render Bash, so that's nice. So like it's just like a simple Bash script, but you can just this is just an example to show that you can get the today's date, and it will render in Quarto, and it looks kind of nice. Uh, and so an example of that with DuckDB is you will use the DuckDB sort of command line invocation. And then one of the arguments to that invocation is this S, which allows you to pass some SQL to DuckDB, and then it will return the output to the like kind of standard out, uh, uh, I don't know, buffer or whatever. So which then Quarto will gobble up and spit out. So it doesn't look quite as nice. Like you get these weird sort of line start symbols, and I'm not sure how to get rid of those. But yeah, I mean you can see it kind of works. It's kind of a pain, but if you find yourself in that situation, you can do it like that. And so this is just a really simple example. Okay, so I'll go. Yeah, I
So
mean
maybe
I'll
one
just kind
quick
of.
point on,
Yep. Oh yeah. Yep.
sorry, because I think now we get into actually using DuckDB, but those
Mm,
arguments that are passed, I thought it was really interesting that they don't follow the sort of Unix POSIX convention of double dashes for long arguments
mm,
and single dashes for short. Um, So like if you tried to get the help menu for DuckDB, it's -help rather than -help.
Oh, interesting. Huh.
And -h does nothing. So yeah, I
Huh.
thought that was an interesting choice that I hope not many people follow.
Yeah,
Cool.
I actually did not notice that, but you're right. I wonder why they made that choice. But yeah, I mean, you're right. Like that is a little counterintuitive. Yeah, I don't know. Yeah.
I would have hoped for like a --SQL or something as well as a -s,
Yeah.
and it's no, there's some short, there's some long, and they're all single dash.
Yeah. Yeah, that's a good. Yeah, I think I probably would have preferred --SQL also, or like I do find that, and certainly for someone who doesn't use the command line version of it all the time, which I think is probably most users, like --dash isn't that descriptive. So yeah, no, I think I see that point. Yeah, I wonder why they did that. Yeah, I don't know. And then there's a little bit of, well, I'll jump to the next slide. So there's these two ways that you can configure the CLI. One is through these dot commands, which you run in the interactive CLI. And so some of those are dot, so some sort of really useful looking examples are like dot open to open like a whatever file you want to open, be it like a .duckdb file or a dot. I think I don't know if it can. Maybe it only works on .duckdb files. I don't know if it works on some of the other formats, like Parquet or something. But it definitely works on .duckdb. Dot tables. I have a typo there, I guess. We'll just list all the tables in the environment. Dot mode. You can use to change the like the output format, which I think I have a slide later on that deals with that. Dot quit will quit. Dot help you can use to get help with. I'm not sure if it only works with dot commands or if it works with everything. I don't know. If, I didn't test that, but it at least works with dot commands. Although I thought the syntax there was a little weird as well. Where I think you have to type like dot help mode. Like if you wanted help with mode, for instance, you type like dot help space mode period. I think so. That's a little unintuitive to me as well, I would say. But and yeah, so similar to I don't know if anyone coming from R probably has seen this mechanism in the .r profile file where you could sort of use R scripting to set up an environment that then gets read in as soon as R starts, and at different levels, at like a project level or a user level or whatever. And so this .duckdb RC file is sort of similar to that, where I believe you specify a configuration, using this using this syntax, sort of if you wanted to maybe change the output mode, you could specify .mode, and then that will get read in at the start of the session. And so yeah, I forget what so I don't have any examples of these dot functions on the Quarto slides because I don't believe they work when you call. So when you call duckdb -s, the dot commands don't appear to function, or at least they didn't when I was playing with this yesterday. So I was unable to render sort of any SQLs with the dot commands, but yeah, they are there. And then some of them are interchangeable with the kind of starting arguments to the. So like I believe there is like a mode, and I'm blanking on what it is, but or maybe it's like -line or something like that to get. I think that's in a later slide, but so some of these, like you can change either using a dot command or using an argument to the CLI when you start it, and so they're kind of interchangeable in that way. Yeah. Okay. Yep. This is that slide I was talking about. Yep. So this is an example of using this argument to the CLI -line, which will give you this. So like, whereas in this one, you can see we have this kind of like table format, which I think they call duckbox, which is kind of cute, I guess. You can choose what your output format, and so here's like a line based format, which works well, as the authors say, like in examples where you're in cases where you have a lot of columns, because a column heavy table would be quite wide, and it would look strange in the duckbox format, but is easy to kind of parse in this format. Okay, so that's kind of that. And I guess you can explore maybe by just kind of play around in the CLI if you're interested in that, and just kind of try different commands. I think it's pretty self-explanatory. It is just kind of configuration options, basically. So I'll briefly kind of describe this extension system, which I haven't played around with too much, but I did a little web research too, to kind of round out my knowledge here. But so you'll see in the chapter, DuckDB has this extension system. And so there are three types, I guess, of extensions. So there are core extensions, which are sort of developed and maintained by the DuckDB team, like the core kind of DuckDB team. There are community extensions, which aren't developed or maintained by the DuckDB team, but do get kind of seem to undergo some level of vetting, like they get merged into a centralized GitHub repository that is maintained by the DuckDB team. So at the very least, when you load one of these extensions, that you're loading an extension from that repository. So it's not like, I don't know that they're validated. I don't know what level of validation they're kind of applying to those community extensions, but there's, it's not like, PyPy or something where like you could just kind of like, it's like the Wild West. It's maybe a little bit more analogous to CRAN or something like that. Although there's, obviously this is like a much smaller, like much more centralized ecosystem than we see in either like R or Python. It's a pretty, and like the list of community extensions, I think there are like probably less than 100. So it's not like there's some crazy number. But yeah, I mean, there definitely are some useful features that these extensions kind of enable that just aren't included in the kind of main binary. I guess maybe for, maybe to keep it small. But, I mean, you can see like there's like an AWS one. There's like a spatial, if you do spatial now, I don't know. Well, I guess later on we use the HTTP one. So yeah, I mean, there's definitely lots of useful functions that can be enabled with these extensions. And so like, both R and Python, to use the extensions, you have to both sort of install them and load them. So, here's an example of that, installing the HTTP file system. I think that's what that stands for, extension. Loading it into like this session. So yeah, you only have to install it once. You load it, every time. Just like kind of probably the languages we're more familiar with. And then in this case, I'm just invoking this query to print a table that shows my installed extensions, and then also the file path. So you can see, like in my case, like the file path is just a subdirectory under my .duckdb directory. So yeah, pretty, it seems like a pretty simple system. And then yeah, if you want to install a community extension, you can append this from community. I thought that was kind of interesting. I don't know if anyone, I was wondering, like, okay, like from is SQL syntax, and sort of like how to understand this line here. It's there's like a DuckDB specific maybe function here, and then I don't know if anyone has any thoughts on that, but again, this extension Quack seems to allow you to produce a little duck emoji, so that's fun. And yeah, this is just a little example that they included at the end of the chapter that shows how you can use an extension to query a CSV file from the web. And yeah, I mean, other environments can do this cool, but it is a cool thing where you can query the CSV from the web. You're kind of pulling it straight into your session. You're not saving it. There's no. It's not like you're downloading it and then reading it. You're reading it straight from its, wherever it lives on the internet, right into your memory, without writing it to your disk, and then you can kind of do analysis on it, which I think is pretty cool. The one kind of thing to note about this is that in this case, in a lot of cases, it seems like DuckDB tries to kind of like make smart inferences about what you want to do. So if you were to use a plain text web address that ended in .csv, it would automatically trigger this read CSV function. But if you have an address like this that is just kind of impenetrable, it has, it can't make any inferences, then you have to specify which sort of reader, which parser you want to call up. But yeah, you're not like calling.
Well, that was an odd choice as well, because like you specified read CSV. You're saying treat this as CSV, and then you have to go to the extra length of really try to treat it like CSV. Like if it was just a generic read, I would understand having to specify, but yeah, that was an odd choice.
Yeah, and it is a little, they're like really simplifying. Like there's no point here where you're, it's not like you're also calling the HTTPFS package like in this function. Like, it just all, I think there's a lot kind of abstraction in the syntax that they use, which, I think can be good and can be bad.
I think I've spent maybe a little bit too long with some strongly typed languages recently, but yeah, select from string becomes a weird thing to write, and then select from read CSV string makes a bit more sense.
Right. Yeah. Okay. Yeah. I see what you mean. Yeah. I definitely am not, I don't know if this is just my feeling, but maybe other people feel the same. I do feel like the SQL syntax is a little bit more casual with its sort of like the data types, coming from R, where I think, there's a lot of, it feels, there's a limited number of data types, and it pretty much every expression only uses like a couple. I know. Whereas, here I do find it a little bit more confusing. Like, you can have this from query, and then, sometimes you can follow it with a function, and sometimes you can follow it with a string. And, I don't know. I do find that confusing. So, yeah, I don't know if that's the same point you were making, but yeah.
Yeah.
Okay, and I think I'm almost done here. This was just their last little example where they show you how to, if you want to pull straight from the internet into sort of a Parquet file that gets saved to your local disk, then you can do that using this kind of query. And I guess maybe the point was just to demonstrate that you can write to the standard out. I don't know what to call it, buffer, directory, but yeah, it's kind of where the output of your shell goes. So yes, you can write to that. And this is something that is not in the book, but I have discovered there is this argument to the CLI that will --UI that will launch a little server that you can access through a browser, and it's like pretty bare bones. Maybe they're going to develop it, but if you prefer that, it is like a kind of a nicer, a little bit more polished. It has a few like it'll give you some automated like distributional visualizations of your data and stuff like that. So that's a little bit, if the CLI is like a little too janky for you, this is kind of a nice way to just use DuckDB. And so that is all I have.
So back to my earlier point, it's single dash.
Oh, this is single dash?
Yep. Again, like you expect any word would be double,
all right.
But yep, it's single dash.
Wow. Okay. Well, I'll make sure to make that correction. And I think I stopped sharing my slides. Yeah, that's so funny. I hadn't noticed that. But yeah, and I feel like they in general I feel like they're pretty user experience focused in terms of how they design the syntax. So it is weird that they made that like unconventional choice. I don't know what's going on there. Okay. And so I think I've stopped sharing, right?
Yeah.
Okay, great.
All right. So thank you, Cory. So let's continue to chapter 3. Now that we are, prime, with the DuckDB CLI. Let me
So I
share my
had just a
screen.
couple of things on chapter 2 still, if we've got some time for discussion.
Go ahead.
Yeah. So I was interested just trying out like reading in empty cards from a CSV that was online, and just doing some like general calculations within DuckDB. One of the things that I found like nice was like a round function. I'm sure that does exist in like a generic SQL, but that was nice to see those. The one I was really interested in, and I know that you used Bash to do the processing there, but with the actual CLI tool, typing into that, it's really hard to add a new line like halfway through your expression. So I'd like pasted in the huge URL that I had for a CSV and then wanted to change like a column to the mean of a column, and like having to go back there and add that, you've got to just delete lines.
You're in mute, Cory.
Sorry, the buttons are different. Yeah. I agree. I mean, I think when I do that, kind of go through the exercises, I probably will use uh, the web UI just because I think for that, like for the reason you said, it like if you do want to make changes and stuff like that, it's a little challenging.
I mean, SQL's never been clean to write in anywhere. I
Yeah.
remember old Access days of having to do like everything on one line, and yeah. The other thing I
Yeah.
noticed just printing it out was that if you do some sort of calculation, like the mean of some columns, the ordering of columns is not stable, which I guess is a database thing. I'm maybe it's not. I don't know. I'm used to that from like dictionaries in any language that the order is not guaranteed. But if you calculate something and just print out the rows for the table and then do it again and again, the rows change. They're not stable. So there's an order by, and you can order by all, which is a DuckDB specific thing. So that will just all the columns will be ordered in, I guess, order of appearance, or I'm not sure.
Hmm.
But
I
that
hadn't
gives you a
noticed
stable
that.
output.
Will
Yeah,
it
so
like
I
oh,
just did
sorry.
like the mean of a column and then grouped by. So I had a fairly short column that I was looking at. And yeah, if you just run it again and again, they move around.
Huh. I guess, and I guess maybe we have a little bit in chapter 3 about like indices. Like, I guess it's, or keys, I guess keys. The key is
Mhm.
probably stable, but yeah, that is weird. And maybe, I don't know, maybe that's something to do with its underlying architecture and what makes it,
Potentially, if it's
faster than
vectorized and it's like
yeah,
chunks
yeah,
it out, then there's no
yeah,
guarantees over the order in which
yeah.
it does those.
Okay. But yeah, that's
But yeah,
definitely
something
something
to be
to
aware of if
be
you're
aware
looking
of.
for
Yeah.
outputs. Yeah, that's all I had for this chapter.
Yeah. Well, I mean, those were some very subtle observations. That was very helpful.
All righty. So let's jump in then to chapter 3. Uh, when I was discussing this with Cory, everyone sees my screen? Good.
Yep.
I
Okay.
could.
So uh, in the Slack, channel, what we're going to do is that Cory would start with the discussion of chapter 2, and then I will start with chapter 3, but you know, only the first, the first sections. So by people that don't know me, my name is Ricardo Serrano. I've been a data scientist since 2018, more or less, 7 years in the in this field. Right now, I'm doing more data engineering projects. So that's my, my motivation, to study more about DuckDB because I know it's very, very useful for doing, creating data pipelines or data flows. So let's jump with chapter 3. Okay. So the key topics that we're going to be working with, we're being introduced to a data set that is going to be apparently is going to be used throughout the book, which is a photovoltaic database, and I'll go in little detail about the tables that we're going to be using. The chapter is basically uh, divided in two sections. What is called the DDL, the data definition languages, which is in SQL, you have certain functions that create the tables, alter the tables, insert rows, etc. The other one is what is called a data manipulation language, with that's where you do the joins, you do the inserts, you do the merges, and they're covering the select. Even though the select usually is not used for doing some alteration, into the information of the database, usually it's something that manipulates part of the information and creates new fields, etc. I'm assuming that everyone has a basic, understanding of SQL, right? Okay, so I don't have to, go into the details. Then the authors also give us a glimpse of what are CTEs, the common table expressions, what are window functions, the joins that I explained, and then some functions that are the DuckDB kind of exclusive in terms of group all, columns, dynamic SQL, and all that. So we're going to see just some examples because more in the next chapters we're going to delve more into those sections. Okay. So the data set, and if you have already, perused, the chapter, the data set is kind of a photovoltaic energy production, in a nutshell. And one of the things that we're going to be, uh, using is basically three tables. Okay, are the readings tables of that database, the systems tables, and the prices. In the reading tables, you only have three columns, three variables. You have a system ID, you have a timestamp, a date, which is a read on ID, and then the power, the power value of the sensor, of what the sensor is transmitting. You will see that even though usually a table has, a primary key, foreign keys, etc., in the readings, those two columns, the system ID and the read-on, joined, the combined, are the primary key. Okay, so be careful with that because usually the primary key is unique and it's not null, right? So you will see that in the system ID and the read on, there's going to be some, repeated values, but combined, you get the primary key. In the system, it's very straightforward. It's just an ID for the systems and the description, the name of the system, and the primary key is the ID. In the prices also, you have that ID, right, from the system, and then you have the value, which is the price, and there's some dates we give you the, kind of, where the price is going to be valid from that date to the end date. Okay, so basically that's, the database that we're going to be looking in a nutshell. Any questions so far?
So
Everyone good?
maybe this is betraying my lack of SQL knowledge, but I hadn't
Mm-hmm.
like does anyone understand like the concept of the foreign key? I know at one point they they made a few decisions. I'd have to pull up the
I
book.
think Andres has
Oh, yeah.
has a comment.
A question.
Andreas,
A question. Sorry.
Mhm.
How does this read on? How does this work? How do you get the data?
The data is supposedly, you can read it in this, site, where they explain, what is the composition of the database. But from what I read, it's a sensor that is transmitting, let's say, a residential, meter. Okay, so every 15 minutes, uh, we're getting readings from that sensor. We're getting readings from which system is transmitting the data, the date that the transmission occurred, and then the power value. Okay, how much the solar panel was generating within that system at that time. Okay.
Yeah. Thank you.
Good. Okay. Yeah. The only thing that is not usually common, in this database is about that combined key. That there's no really a single primary key. In the readings, there's a combine, which is the system ID and the readum. Both of them, that per value, it will be the primary key. Okay.
Also, just shuddering at the idea of combining anything with a date and trying to use it as a key and not using a Unix timestamp.
Right. Mm-hmm. Yep.
But I guess that works.
Yeah. And usually, you will see it, especially when you don't have, a column that can be a primary key. And I have seen it in all other instances in real world data sets where sometimes there is no ID. Okay, you have to create it. When you create it, you then try to visualize. Okay, which are the columns that I can create a unique value, from the values of those columns, and then I can create my ID. Okay, kind of a surrogate ID. Okay. All right. So we're going to be doing some scripting here. I already have, the file and everything just to make the discussion, use the time more wisely. So because I started with R, I did the script, which is, the examples that the book, is showing on. They're already there. All right. So does anyone have a preference between R or Python? That's another question that I had, for the group, because I can do, the
For
next
me.
one. I can do it in Python.
That's just our.
Those are okay.
I
Okay,
think
so
I'm probably indifferent. I'm trying to get more Python practice. So if but yeah, I probably like R better.
okay, so let's stick with R then. All right. So in R, you're going to load only the DuckDB library, and that is a very advantageous thing because DuckDB is kind of a batteries included object that it includes almost everything that you need. Of course, Cory mentioned that there's some extensions. Not everything can be bundled, within that package. So, for example, if you want to read an Excel file, probably you need an extension. If you want to read a URL, right, you probably need an extension, etc. But from what we need from the book, you only need one library, DuckDB. Okay, so let's install it. All right. My console is right here. Let me clear it. Okay. And then the next step is to create a connection. When you work with SQL databases, you usually make connection. That's the same Python in R or almost any other language. You create a connection to that object. Okay, it's like I remember in a webinar, this says so someone is telephoning, somebody on the other side. You're telephoning the database. Okay, And you can do it in memory, right? If you want to do it in memory, you can use this instruction, dbconnect duckdb. And as a matter of fact, dbconnect is not really part of duckdb. It's part of what a library called dbi. But duckdb, when you load duckdb in R, you automatically load that dependency, dbi, just to make sure that you know what is coming from duckdb and what is coming from other packages in R that are already loaded there. So if you want to do it in memory, like we did, with the CLI, if you do it in memory, uh, you you invoke that statement. But if you want what is called a persistent database, one that you can then write to the disk and then use it, later for different analysis or the different ways, then you can do it this way. The same with the DB Connect. You're going to, log the DuckDB object. Then you're going to say where you want to create that database, the DBDR. And it's going to be in this folder, the working directory that I'm using. And then we're going to name it chapter dash ch underscore 03 chapter 3 .db with the extension .db. So we know that it's a DuckDB database. And the read only usually is false. We're going to stick with false. If you say true, then you cannot, it's only read only. You cannot write to it. All right. So let's run that, right? Okay. No messages. So we are, almost positive that the file was created. If you want to go here at the files in the console, I put refresh here, right? Okay, and the file is here. Okay, so that worked. Good. Now, let's see from the database that we have created, what are the tables? How many tables are there, right? So to list all the tables, you're going to use the dbget query, which is also a dbi command. You're going to invoke the connection, right? The DuckDB connection, and then run this query in that environment. And in this case, it's going to be show tables, right? So if you run this show tables, you see that there's no rows. Okay. In other words, we don't have any tables, so far, because it's a brandly new created database. Now, I'm going to follow, the order of the book. So let's say that we want to create a table called systems that you already saw in the schema of the database that we're going to be working on. So the command to create a table is simply create table. Now, DuckDB, or the authors mainly, they say that it's a good practice to add something called if not exists. All right. So when you create a table, you can do a create a table, systems, and the columns that you want to that you want to create with the type. That's fine. But if you add that if not exists, then what is going to happen is that the table is going to be created one way or the other. If it exists, nothing will happen. It's not going to, go over it. It's going to say, okay, the create table. If it exists, that's fine. I don't have to do anything else. But if it doesn't exist, then I'm going to create the schema, right? And one of the things that, I had to, go to the dictionary is a term that it was the first time, that I stumbled with it, which is called idempotency. Okay. So idempotency, what it is, and I'll give you the definition of that word, is that it's an operation or request that can be repeated multiple times without changing the result beyond the initial execution. So for example, in math, if you multiply anything by 0, what will be the result? If you multiply anything by zero,
Zero.
what will be the result?
Zero.
Don't think it too much. Yeah, zero, right? Let's say that you repeat it 10,000 times, that operation. What will be the result?
Still zero.
Zero, right? Okay. So think about this, with that if not exists. Every time that I, create a table, etc., if I put that if not exists, what it's going to do is that it's going to verify if that table exists. If it exists, it doesn't do anything. If it doesn't exist, then it's going to create something. It's going to create the schema that we're going to be, working on. Now,
So just for a mental model, I think multiplying by 1 might help with the idea of it shouldn't do anything. And I use the word identity has a similar word that you should always get the same thing back. So
right.
it should have the same operation, and you like
Yeah,
if you do it again, you should still only have the same thing left.
correct. Correct. I took an example from the definition. Okay.
Yep.
But yeah, it works with 1, 2. Yeah. Okay. So when we create that table, right, we're going to create the system tables. And going back to our schema, right? Going back to our schema, that system table only has 2 columns. It has a column called ID, which is the type is going to be an integer, right? And the name, the description of that system, which is going to be a character variable, okay, string. So here, we're going to add something else, and just taking the example from the book. So we're going to create a table, if it not exists, systems, parentheses, we're going to say ID, which is the name of the column. The type of the column is going to be integer, and we're going to add that that's going to be the primary key. All right? So remember, primary key are unique. They have unique values, and they're not null, okay, in SQL. Then, comma, we're going to create also the name, the description, with a var right? The character variable, but it's going to be a length of 128. I believe the most that we can get in, at least in SQL, in traditional SQL, is 256. Okay, but I don't know if DuckDB, goes beyond that. I really don't know. I have to check. But we can, have the length of that var character to the length that we desire. And we're going to stipulate also that it's not null. In other words, when you are entering the information, the system is not going to allow to enter something that is blank, that is null. All right. So if we create this, let's say if we create it, right? We run this db execute for that query. Okay. It gives you a moniker of, the brackets 1 and 0, meaning that, yeah, I created a table, but there's nothing there. And let me check if we really created that table in that database. So let's run show tables again, right? And as you can see, there's something here. Let me see. I can move it. Great. All right. So right now in chapter 3, ch_3db, we have one table, which is systems. Okay. So let's create the other tables. We're going to
Just
create a
before we
read.
do, can I'm guessing it does work, but the DBI helpers, like DB list tables, I assume that also works here?
Let's try it.
Yeah.
I'm pretty sure they do. I think I've done that before.
No, so not a different query, but there's a DB list tables.
DB list table.
In our
Okay.
function.
Instead of DB get query.
Oh, okay. Yeah. Okay. Yeah. Right here.
So
Yep.
you have to run that on the connection, but yeah.
Okay. It says something is
So
missing.
with connection as an argument. Yep.
Yep. There you go.
Okay. But it does print
Okay.
differently.
Well, it
Yep.
gives you a
Right.
So
proper
it just
list
lists
back.
the table.
Yeah. Gives you a proper list
Yeah.
back instead of this
I'm trying to stay SQL, SQL centric here. Okay. But yeah, if you have that function, within the package that comes with the DBI, you can use it too. Good. So let's create the other tables. All right. As you can see, the readings also has system ID, integer. We're not saying that it's the primary key anymore, right? We're just saying that it's not null because there's the combination of system ID and read only, that table creates that primary key. So we're going to create the readings with system ID, integer not null, the read on, which is a timestamp, okay, it's a date time field, not null. We're going to create a column called power, right, to store the power reading that is coming from the sensor. It's going to be a decimal, but it's going to be a decimal of 10 characters, which of those 10 characters, 3 are going to be, after right to the decimal point. In other words, it's going to be 3 decimals there. All right. Something that, you have to be careful because the 10 is the whole length of the, of the number. And from that length, in this case, 3 is going to be the places for the decimal characters. Okay, so you have 3 decimals, and then the other 7 are going to be left for the integer part. Everybody got that? Good? Okay, and also, following the example, we can establish a default for that for that column. In this case, the default is going to be 0. So if, for example, the sensor doesn't transmit any value, which if we don't put default as 0, is going to be null, right? So instead of null, the system is going to default to 0. And it's going to also check that value, the power, is not going to be a negative number. It's going to be 0 or something positive. So there's a lot of validation that you can do when you're creating these columns, which is pretty good, because you know that sometimes systems that lack validation, then you have a lot of data quality issues. So the primary key, like I said, is going to be the combination of system ID and read on, which are both are not null. And then there's going to be a foreign key, which is the system ID, which is the foreign key to the table systems with the column ID. This is right here, okay? So it's going to reference, to that table. So already, establishing kind of a relationship within the database. All right? So let's execute that. Okay, gives us 0, so we should be good. So let's show the tables again. So now we have readings and we have systems. All right? We only have 8 minutes, so I'm going to leave you, to check, what is happening, with the create of these prices. Andreas, yeah, you have a question, comment?
Yeah, I missed about 2 minutes. Can you go back to the here you are defining primary key, system ID, and read on.
Yes, it's a combination.
Okay,
You're combining 2 columns into the primary key. Okay, it's just not one.
But
okay,
you didn't do that. But you didn't do that to when you define system ID. Or
no, because in system ID, there was only one, and that ID, that column ID, is going to be our primary key. Okay, remember the primary key in SQL, in the SQL table, it has to be unique, and it cannot have any nulls. Okay, those are the rules. Those are the rules.
ID consists of 2 variables, right?
ID is just one column, one variable.
Okay.
Okay. All right.
Yep.
And just to clarify too about the foreign key, if people don't remember how that works, the reason why you have to tell it that that's a foreign key, you don't actually have to. It'll still work.
You don't have to. No.
It makes it more efficient. It also makes it establishes certain guarantees. Like it won't let you insert a row if that foreign key does not exist in the other table.
Correct.
So,
yes.
In the reference, yeah. So it'll check these things.
Yes. If you want to add, for example, the sensor, sends you some information, it's kind of a corrupt information because something happened, inter-transmission. If the system ID is not in this table, system ID, the ID column, probably it would, it won't store it. Okay, it will give you an error.
Yeah, thank you. I was wondering about that. That was helpful.
Yeah. Okay. But yeah, these are relationships, relationship objects that you can set within your schema, so you can assure that there's some validation within, the primaries and foreign keys of each of the tables. All right. So I'm going to leave you with this one, okay, because this one has a sequence and also, creates the table. But this is the price, the price table, okay? And I know it's going to work because I already, I already did it before. So now we have three, right? We have our systems ID, we have our readings ID as a table, sorry, and we have our prices table. So let's say that we want to query, but instead of showing the tables, you want to show what the prices table is about. Okay, we know what are the columns, how are they defined, etc. So you can use the same show statement, but instead of tables, choose a table. In this case, show prices. So let's do that. And you'll see here that you have a lot of information about the composition of that table. You have the column name, you have the column type, right? You have if no values are valid there. In the three cases, it's not. You have a primary key, right? Which in this case, in prices, in this case, is the ID column in prices. Not, you doesn't have to do anything with systems ID, right? It's another table. This is the prices ID.
I'm going to have to jump off early, but thank you, everyone.
Okay. Thank you, Jonathan.
Thank you.
All right. And from the valid from, the only thing that you have to be careful is that it has to be unique. Okay. The date has to be unique there because it's saying it right here. Unique from, valid from. Okay. So let's see if we can get something else, right? So let me have 2 more minutes so we can cover a couple of things here. So once you create a table, let's say that you forgot to add a column to the prices, okay? And that column is called valid until because you had valid from and valid until, which is where the prices for that system is going to be valid. So you can use the alter table statement. You write the table that you want to alter. And then with this statement, add column, you're going to add any column that is not already there, right? You don't want to add columns that are already there, just columns that are new. But eventually, if you add the if not exists, if the column exists, it's not going to do anything. But if it not exists, then it's going to add it. So we have that kind of item potency rule there. So we know that the column is going to be there. It's going to be added one way or the other. So let's run this, right? And then let's say show prices, right? So now you see before we ran the alter table, we had three columns, right? Now we have 4 columns. So we added another column, which is valid until. So now we have our schema for prices is now completed. All right. That also, one more thing. If you want to add, they call it CTAS, okay? Copy table as. If you want to duplicate a table, you say, you use the create table command. You use the new name for the table as, and then use the select statement. So in other words, you're going to duplicate the prices as select asterisk, select everything from the table prices, from the one that is already there. So if we execute this and say show tables, right? So now we have the 3 tables that we created plus the duplicate of prices, which is prices duplicates. All right.
I was starting to wonder about the memory behavior of some of both with the copying and with views. You know, I know in R, it's copy on modify, I think, where I think
Right.
Python too, I think, where, you know, if you just have a variable that references another variable, it's only using one sort of memory, you know, one table's worth of memory, but the second you've modified it, then you have 2. I wonder how
I wouldn't be surprised that this is the way DuckDB, you know, works.
Okay.
Because I know that DuckDB, you know, they have put a lot of thought on efficiency, okay, and speed. So probably maybe there's a pointer, you know, many ways to do it, okay.
And I wondered with the views too, which I guess we'll get into next week. If you reuse a view multiple times, are you creating
exactly
copies?
With the view? What it's doing is that instead of creating the table physically, what it's going to do is that it's going to create an instruction, an object that has the instructions to construct that, you know, pseudo table. But it's not, you know, it's in the database, but it's not storing anything. Okay, it just has the instructions for, you know, creating that particular view, which has, you know, a lot of advantages. All right, so let's stop here and then we continue on our next, you know, meeting. We'll continue with how to create a view and, you know, what's happening, you know, under the hood.
Awesome.
Okay.
And thank you so much. I thought that was really thorough and helpful. So here I'll stop the recording if I.
Yep.
Oh wait, my keyboard isn't working here. I know.
I can do it from my end.
Oh yeah, that'd be great.